Conditional probability is finding the probability of an event when you know something else has occurred. So, as you can see here in my example, suppose that we know that the probability of H, the general golfer, of making a hole in one is 1 out of 12,000. All right, so pretty rare. But let's suppose you have the additional knowledge that the selected golfer is a professional. At that point, then the probability changes to for him making a hole in one to 1 out of 2,375. Quite different. We're still looking at the probability of a hole in one, but we have additional knowledge. So this brings us to a different formula. We're going to look at what's called conditional probability, the event that something's occurred knowing that something else is already. So the probability that B occurs given A. So here's the thing, this given word is represented by that line right there. So the probability of B given A. So you can see that I've got a formula down here. The probability of B given A is the probability that A and B occur divided by the probability of A. So this is a formula that you will be given on the exam, and this is one of the few formulas that I very strongly recommend that you do end up using. However, having said that, you actually have already looked at a problem like this because we've already looked at the tree example in class where we were talking about the population changed. So let's take a look at this example here. Let me get rid of that. All right, so we've got students at the University of New Hampshire, 10,000 course grades. All right, we got a table that breaks it down, A's, B's, below B's by their school, whether liberal arts, engineering, health and human services. So choose a University of New Hampshire course, define a low grade as one is below B. So I want to know the probability that they get a low grade given they were in the engineering department. So again, we can do this one of two ways. We can look at it just as the population has changed given the engineering department. So if I add up the engineering department, which is right here, that gives me 1,600 grades. I want a probability that it's a low grade given or out of the population of the engineering department. So that is 800 out of 1,600, which is 0.5. Well, if I wanted to use the formula for this, B given A. So it would be the probability of A and B divided by the probability of A. Okay, well, A and B would be probability that they were in the engineering department and got a low grade. Well, that would be 800 out of the 10,000 total, divided by the probability of A, which is the probability that they were in the School of Engineering, which is 1,600 out of 10,000. Okay, well, you can do this on the calculator. You would do the top fraction divided by the bottom fraction. And you're going to find you're going to get 0.5. So the same thing as we had before. All right, either way is going to work. It's just a matter of which you deem easier. Here again is a situation where if I have the raw data, then I think just using the raw data is probably easiest. So looking at that, actually, let me get rid of some of this stuff up here. Okay, so looking at another example. Probability that they got a low grade given they were in the liberal arts department. So my new population is the liberal arts department, and that total is 6,300. That's all of these. Low grade given they were in the liberal arts department. Well, here's our low grade. So that is 2,268 out of the 6,300 in the liberal arts department, which dividing then would give you 0.36. Now, here again, if you have the raw data, I encourage you just to kind of rationalize it out. If you don't have the raw data, however, let's suppose they just gave you Probabilities. That's where you do need to use the examples or the formula. So let's suppose a math teacher gave her class two tests. 25% of the class passed both, 42 passed the first test. What percent who passed the first also passed the second? So some of this is being able to rewrite it. So I want the probability. Oops, I got it here. All right, so with the probability that out of those who passed the first, that's my given. So out of those who passed the first, how many also passed the second? So using my formula, B and A, which will be the probability of A and B, meaning the probability they passed both, divided by the probability of A. So looking at my data, 25% passed both. So that's my and, 0.25. 42 passed the first. So we're taking 0.25 divided by 0.42, which is 0.595. Okay. As another example, using the formula, the probability that Sam parks in a no parking zone and gets a parking ticket is 0.06. The probability that he can't find a legal parking spot and has to park in no parking is 0.20. So Tuesday, Sam arrives at school. He has to park in a no parking zone, find the probability he gets a parking ticket. Again, some of the hardest part of this is just rewriting. Think about what you know. Whatever you know is the given part. We know that he parked in a no parking zone. And then what are they asking us? Okay, well, what's the probability he got a ticket? So that's again going to be, so B and A, the probability of A and B divided by the probability of A. So the probability that he parked in a no parking zone and got a ticket was 0.06. The probability that he had to park in a no parking zone is 0.20. 0.06 divided by 0.20 is 0.30. So again, we've got a situation where if you have raw data, just do it as a regular probability because you have a new population. If, on the other hand, you don't have the raw data, all you have is probabilities, that's where the formula comes in. Okay, if you have any questions, again, please reach out. Yep, and we will hit section 4.4 next time we're in class.